April 16th, 1972. Apollo 16, men's fifth lunar landing, sat silently on the pad awaiting its mission. And inside the astronaut quarters, its relaxed crew ate Sunday breakfast. John Young, the commander of the mission. Ken Mattingly, command module pilot. He will conduct orbital experiments around the moon. And Charles Duke, he will explore the lunar surface with Young. But to do this, they went through training for months, and they were prepared for every possible scenario. Like every Apollo landing missions, this one will contain two separate spacecrafts. Command module will carry the astronauts to the moon, and it will carry them back to Earth. They used simulations, spent hours to learn how to operate the spacecrafts. But different from Mattingly, John Young and Charlie Duke trained for the lunar landing vehicle. While Young operates the spacecraft, Duke will inform him about the fuel, altitude, and landing angle. The mission objectives included conducting lunar surface scientific investigations, deploying and using the lunar roving vehicle, which will help them to explore more area and gather various soil samples. They will deploy the experiment package called AL-SEP, which contains a magnetometer to measure the moon's magnetic field, a seismometer to measure the forces resulting from meteor impacts and moonquakes, a solar wind spectrometer to analyze the composition and energy of the solar wind particles hitting the moon's surface, a heat flow experiment to measure the amount of heat coming from the moon's interior. This will help to understand its thermal characteristics.
This is Apollo Saturn Launch Control. We're at T-minus 3 hours, 30 minutes, and counting. T-minus 3 hours, 30 minutes, and counting. We'll go into a built-in hold at the 3 hour, 30 minute mark. We actually have 44 seconds to go toward that hold. This is a planned hold at this time. It's built into the count to take care of any contingencies that might come up during the cryogenic loading. Actually, that cryogenic loading has gone very smoothly this morning, and the liquid hydrogen and liquid oxygen are now aboard the various stages of the space vehicle. Topping off of these full fuels will continue down to about the 3 minute mark in the countdown. Out at the pad right now, the primary damper arm, which connects to the space vehicle and is used to dampen any oscillations due to the wind, has been moved back. Once the fuels are brought aboard, it's no longer necessary to have this damper arm down there. We're now approaching the 3 hour and 30 minute mark. T-minus 3 hours, 30 minutes. Don't we have a hold? No, not yet. This is Apollo Saturn Launch Control. We're now at T-minus 3 hours, 30 minutes, and holding. This is the final planned hold in the countdown. The closeout crew is now on station. They've opened up the spacecraft and are generally preparing it to receive the astronauts. Astronaut Tony England is part of that closeout crew. He's in the spacecraft at this time and is performing a variety of functions. Among them are setting communication switches, turning on panel and other spacecraft lights. He also injects chlorine into the drinking water and adjusts the breathing oxygen. He'll remove the guard over the pyro arm switch and cycle the pan and mapping cameras. Generally, he's preparing the spacecraft for the arrival of the astronaut crew. Topping off of the cryogenic fuels continues at this time, and our weather for launch time continues to look good. Now at T-minus 3 hours, 30 minutes, and holding in the planned hold, this is Kennedy Launch Control. This is Apollo Saturn Launch Control. We're continuing in our hold at the 3-hour, 30-minute mark. This hold was scheduled to be completed at 9:24 this morning, and we were scheduled to resume the count. There is a possibility that we may have to extend the hold. During a flight control systems checks this morning, some data indicated a momentary dropout of output from a spare rate gyro. The primary system has passed all tests successfully. The data is being evaluated at this time. It may be a problem which is due simply to ground support equipment, but the spare gyro is an airborne system. It would be used only in the event of the primary system failing. The spare gyro is located in the instrument unit of the Saturn V space vehicle. We're continuing to evaluate this problem. At this time, we're continuing in the hold at T-minus 3 hours, 30 minutes. This is Kennedy Launch Control. T-minus 25, 24, 23, 22, 21, 20, 19, 18, 17, guidance release, 15, 14, 13, 12, 11, 10, 9. We have ignition sequence start. The engine's now building up to 7.7 million pounds of thrust. We have a launch commit and we have a liftoff. The swing arms moving back. The Saturn V lifting off the pad, building up thrust. We've cleared the tower.
Houston is now controlling.
Oh, you have good thrust in all five.
Roger. Pitch and roll program started. 16 now maneuvering to its proper flight path attitude. 2 minutes 40 seconds coming up on staging.
Staging. Okay, ignition on the S2. Roger.
2 minutes 53 seconds. A normal staging. Young Duke Mattingly now riding on 5 good second stage engines.
Go on all 5 on the S2.
3 minutes 2 seconds. The giant first stage falling away now. It's a day's work completed.
Apollo 16 had settled into Earth orbit, but now they will have to make a burn to escape the Earth orbit. This burn will start their 3-day journey to the moon.
16, we're showing good thrust on the S4B. Roger. Roger.
Booster reports shut down on time. Guided cutoff.
Now it was time to dock with the lunar module, the spacecraft that they will use to land on the moon.
Corey, looks like Orion hanging in there pretty well. She looks great.
Looks the same to us.
Okay, Houston, we're hard docked.
Roger, John, we saw come in.
And there is no question when you get the ledges.
Yep.
After docking with the lunar module, they opened their TV camera to share their view with us.
Oh, very nice picture, Charlie. We can see southwestern United States, lower California. Very nice.
Good. Ken's doing all that good work for you. It's out his window. Gordy, is that color okay for you?
Very nice, Ken. Beautiful color.
I bet it's good, but you just can't believe how beautiful it is. The reds in the desert down there in southern United States and northern part of Mexico. And from here you can see the Great Lakes and state of Florida out there, and it's just absolutely something. We're going to go back to work, but thought you'd enjoy that.
Thank you for the picture. It's the next best thing to being up there.
Apollo 16, Houston. Apollo 16, Houston.
Good there, Houston. How you doing?
Hey, you sound good. Good morning up there. How are you doing?
Great.
Good. All your systems look
Sure beats work.
good show. Everything looks fine up there from down here.
Oh, yes. Sure beats work.
How your comrades doing?
Oh, they're just starting to stir.
I'd hum something for you to wake you up, but I got a tin ear.
We'll make it, Tony. Okay, for Ken, he had from VLC everything but pecan, and he ate his sandwich and his orange juice. And we got on me now for my meal. I had the sandwich and the orange juice that was in the soup. For VLC, I had half the spaghetti, all the ambrosia, and the cocoa. I got about 5 hours sleep with about a 20-ounce fluid intake. Over.
Okay, I got it all. Sounds like you all slept pretty good.
Well, it was off and on for me. I must admit.
I tell you, I'd be so excited I wouldn't sleep at all.
Okay, we can see the Earth out there, and it's getting a good deal smaller. It's about the same size as the moon, almost out the other side. And Africa is clear this morning, at least the part that we can see, which is what's usually clear, right around the Canaries and so on.
As the astronauts neared the end of the second day, they noticed a problem with the computer, one of the most crucial components that was not supposed to have any issues. Ken Mattingly was adjusting the spacecraft's trajectory when warning lights started to flash.
Casper.
Hello, Casper, go ahead.
Okay, I'm not sure what just happened. I just saw down looking at the optics, and all of a sudden I saw a warning light, and I got a no attitude and a gimbal lock light. And my ball seems to, in fact, looks like the platform may be frozen.
The tasks of maintaining the Apollo spacecraft's stability and orientation were handled by a gyroscope connected to the computer. If the rings of this gyroscope came too close together, the computer would automatically lock the gyroscope's movements. To use the gyroscope again, it had to be realigned by referencing the positions of the stars. For an unknown reason, the computer locked the gyroscope, and Ken Mattingly had to use the stars for realignment.
The astronaut navigator finds a known star in the wide-angle telescope. Using a fingertip control, he changes the attitude of the spacecraft to bring the star into line. Once he has the star in position in the telescope, he moves the optical sextant. He lines the sextant up with the star and makes a reading. He must repeat the process with another known star so that he has 2 readings to give to the onboard computer. From this information, the computer determines the attitude of the spacecraft. Once the attitude is known, the 8-ball can be aligned. This device, similar to those used in airplanes, is stabilized with gyroscopes and connected directly to the computer. To the astronaut, it's the most important display next to the computer itself. When set, it becomes the primary guidance instrument in the spacecraft and is used to orient the spacecraft for the mid-course maneuvers. This information is vital to their mission, particularly for the mid-course adjustments they will have to make when their engine has to be accurately aimed for firing.
But there was another problem. At the beginning of the mission, when the lunar module docked with the command module, they noticed that the command module's thrusters were much colder than they should have been. Each time these thrusters were used, the surface temperature of the lunar module dropped more than it should have, causing the paint to freeze and crack off. This resulted in small paint chips floating around the spacecraft. These particles made it impossible for Mattingly to perform the star alignment. This left only one solution: to use the most prominent star in the sky, the sun, and the other brightest object, the moon. Mattingly successfully completed the adjustments using the sun and the moon. Subsequent investigations revealed that the issue was caused by a short circuit in the computer. The short circuit triggered the computer's safety mode, which locked the gyroscope. The crew lost sleep over this issue, but fortunately, it was not a problem that threatened the mission. After spending dozens of hours in space, they had finally reached the moon. But the spacecraft was too fast to enter lunar orbit. Therefore, the spacecraft needed to slow down. To slow down, one final burn had to be performed. Since this burn would take place behind the moon, they would lose communication with Earth, and those on Earth would have to wait for minutes to find out if the burn was successful.
16, we're a couple minutes from LOS. See you on the next pad.
Okay, we'll be there. Apollo 16 spacecraft has passed behind the moon a few seconds early, according to the loss of signal clock in the control center here. The total delta V, or velocity change, will be 2,802 feet per second in retrograde.
They have waited for a signal.
Have confirmed AOS.
Hello, Houston. Fleet 16 has arrived.
Roger 16, copy loud and clear.
Okay, Pete, super double fantastic burn.
Very nice.
Apollo 16 had reached its temporary home. After completing some checklist, the crew could finally rest.
Well, he's looking out the window. And right now we're looking right down at Crater King. And it's just as fantastic as it always has been.
Roger.
You can see those little dark, look like volcanic black spots up in the north sector of it, and you can see the central peaks with a very white central peaks covered by lighter gray brown material. It sort of looked like somebody painted it on there with a paintbrush. And Pete, your first view at Tsiolkovsky from our one is it's a spectacular sight with that like a marshmallow floating, a central peak floating in the top of a hot chocolate. Yeah, it's like three guys and each got a window and we're staring at the ground. It's really, boy, this has got to be the neatest way to make a living anybody's ever invented. Pete, 16 here, another pretty sight we had before burn was the Earth set that really Quite a few. How'd the S4B look?
It hadn't happened yet, John. It's about another 9 minutes or so.
I trust we're not getting there at the same time it does.
I trust.
Okay.
After routine checks and preparing the lunar module for the landing, the crew went to sleep. Tomorrow was the big day. Young, Duke, and Mattingly, 380,000 kilometers away from Earth, 160 kilometers above our scarred satellite. They woke up for their descent. Capcom notified them that their potassium levels were low, and to make them raise, they suggested the crew to drink orange juice in their breakfast. And because they have a long day ahead of them, they also asked them to eat more than usual. After the crew ate their breakfast, they started to prepare the lunar module for de-descent. But when they were doing it, they realized there was a malfunction with the antenna. Via this antenna, and the operations on the computer were thus carried out. If the computer failed, the landing wouldn't be possible. This was a critical malfunction, and the only way to fix it was to go outside and free the stuck antenna. Apollo 16 didn't have time for going outside. Every passing second was working against them. They couldn't afford to waste the already limited resources inside the module and put the mission in even greater jeopardy. There was only one thing left to do. Mission Control would give the data to Charlie Duke instead of sending it to the computer. Charlie would then manually enter this complex data into the computer without making a single mistake. And the green light for landing was given.
Oh, Houston, all right. How do you read, over?
Ryan, this is Houston. Read you loud and clear.
Okay, Jim, we're zipping right on through the checklist. We got the pings up, the docked course line done, the landing gears deployed, and the only thing we haven't done is really what you need to see, and we're ready to start in on the S-band checks and bring up the steerable, over.
2 spacecraft had disappeared into the far side. Ken Mattingly has to perform a circularization burn, while the lunar module will stay in its current orbit. This stable circular orbit for command module was essential for simplifying the rendezvous and docking with the LM, ensuring fuel efficiency, and facilitating mission planning. After an hour waiting for Casper and Orion, they finally rose from the lunar horizon. But they had some bad news. Mattingly did not make the circularization burn. He found some error in the command module engine. There are components that allow the command module's engine to rotate around itself. The purpose of these parts is to ensure that the command module's engine operates facing the vehicle's center of mass. Due to the separation of the lunar module, the center of mass of the vehicle changed, and while the engines should have automatically adjusted to this angle, they couldn't find the correct angle. As a result, the engine kept moving continuously, trying to find the correct angle, but failing to do so, making ignition impossible.
Yep, and telegram when you go around.
Okay. Weather ready to start today, huh?
Yep.
We'll be requesting high bit rate shortly.
Roger.
And we're ready for high bit rate now.
Copy, no sir.
We copy, no sir.
It was a mechanical malfunction. Mattingly couldn't do anything to fix it. 1 hour before the scheduled landing, a decision that had never been made in previous Apollo missions was given. The landing was canceled. They were instead of given the task of continuing station keeping and drifting in the empty space with Casper until the mission control comes with a solution. John and Charlie looked down as they passed their landing site many times. They realized the hard truth. They may never land on the moon. Their only option was the dock with the command module and return home before any more issue develops. But all three of them waited and hoped for the good news that will come from the ground. Have they really come all this way? Spent months of training for nothing?
How long do you think it's going to take them to get rendezvous, Jerry?
I think your estimate of a couple of 3 res.
Because of the main engine had issues, they come with a solution to get them back to Earth. They were going to use the lunar module's engines for the burn necessary to escape lunar orbit and get back home. 2 spacecraft get close enough to dock in case the mission control doesn't come with a solution.
Get them back together, get the things back if they want them, get them mentally prepared to do what they're going to do.
But now, don't take that as input. I'm talking out loud. I want to say something unless I'm sure of.
I don't see any way we can continue on.
At that moment, chances for a landing was pretty low.
We should make sure that that's calm, but there's no way, you don't have any other redundancy or other routes?
In the lunar orbit, Ken Mattingly in the command module, John Young in the lunar module, prepared the spacecrafts for docking.
Why don't you tell me what to do there, John?
Okay.
Word's coming back kind of initially from North American that they're suspecting a rate feedback.
Building 45 is Jim McDevitt.
The team for searching the trouble was getting bigger. Not only NASA, but many universities, the manufacturers of the both spacecrafts, they were all come together to find the solution.
You can't use it if you get a broken wire, you don't know it's going to come back again.
Me now like I'm drifting the other way.
Not according to my needles.
Okay, I'll believe your needles.
Of course, then you would have had no options. Okay. I mean, then it's full speed ahead.
They called the astronauts who flew with Apollo missions before to ask their opinion about the situation.
So you'd only do it if you had a failure on the primary. Well, how would you ever get the damn thing trimmed then?
Well, I would, if I had a failure in a primary, I'd shut it down.
Well, we must be going in the right direction then.
Yeah, you're going to get there.
The results were coming in. It was beginning to pay off. The simulator tests and other data were showing that with the engine on, they could make the burn without any issues. Despite their earlier concerns, it was beginning to look pretty good.
Okay, when you come up on AOS, on the next Rev 15, we'll give you a go or no-go for another try.
John and Charlie orbited the moon one last time, and when they were on the lunar horizon, they were given the green light. They were going to the moon.
Go at 9.
Okay, we're out at 12,000, John. Go at 9, coming down at 182, a little steep. Okay, well, we're going to be right on, just about right on, maybe 10 feet, 10,000 feet. Stand by. Be 64 at 8,200. Pro. Pitch over. Pitch over. And here it is, Gator, Lone Star. Right on. Thanks, Charlie. Okay, 40 degrees, 38 degrees. Right on that on dot, north right. Okay. Looks like we're going to be able to make it, John. There's not too many blocks up there.
Ryan, you go for landing.
4,000 feet.
Okay, go for landing.
42 LPD.
42.
Okay, 3,900 feet.
Okay, 2 to the south, Charlie.
Okay. It's in. Okay, 42, 41 LPD, 30,000 feet on profile.
Okay, there's, we're coming right down, it's gonna be a little past,
Okay, 41 LPD.
okay.
10,000 feet, 60 on profile.
Okay.
Okay, 42 LPD. Couple of more in. 1,400 feet, 44. Down, looking good. Out of 1,000 feet, right on profile. 54 LPD, dropping out the bottom now. 800 feet, 30 down.
Hey, Houston, we're gonna be just a little long.
Roger.
But, we're just now being, double spot.
Copy.
Okay. 23, 22 down at 500 feet. Big blocks over here to the left, John. Okay, 300 feet, 15 down. Okay. Okay. Take over, Charlie. Okay. Okay, fuel is good, 10%. That comes the shadow. Okay, 200 feet, 11 down. Give me a couple clicks up. Okay, 5 down at 130 feet. 2 forward. Okay. Almost, Christian. Okay, looking good. Perfect place over here, John. A couple of big boulders. Not too bad. Okay, 80 feet, down at 3. Looking super. There's Dust. Okay, down at 3. 50 feet, down at 4. Give me one click up. Backing up slightly. Okay, 2 down. Stand by for contact. I'm gonna let her down. You level off. Let her on down. Okay, 76%, plenty fat. Contact. Stop. Slow. Engine arm. Wow! Oh, man! Look at that. Engine arm. We finished command override. Okay, 413. And then, check the app. And we don't have to walk far to pick up blocks. We're in front of them. Open, close, open, close. Pull a run and finally here, Houston. Fantastic.
That's great.
I can look right out to the left and see.
Let's go aft, Omni, all right?
Double spot. We're about, okay, you got it. Okay, we're forward to the north, forward and to the north of double spot. I would guess about 200 meters to the north and maybe 150 meters to the west. It's not flatlands though, Houston.
Roger, I copy 200 meters north of double spot and about 150 meters west.
Yeah, and I could see all the way to the ground, just like flying the LTV. Piece of cake. That's good. Asset pressures look good. Okay, asset helium monitor cycle I did. O2. Asset LED. Fantastic. Percy Precision is Planet 1 on the planes of Descartes. Well, camera stop. I better go easy on this landing radar circuit breaker, huh? Yeah, don't. Okay, that's the right one. The camera's off. Hey, it sure ain't flat, John. Wow, there's that ridge to the north. Yep, sure is. All we got to do is jump out the hatch and we got plenty of rocks. Houston, boy, it sure looks like you can make, I see Crown Crater from here. I can see Ray Crater from here. Not a, boy. Almost had apoplexy, that program alarm, and that's your radar breaker. Charlie's got nothing but a ridge to look at.
That sounds beautiful, John. Wish I were there.
There's a ridge out. There's a ridge out in front of us too, John. Yeah, there's a ridge in front of us, one to the side of us. And my guess is that we're in a subdued old crater that's got a lot more craters.
Roger, we copy.
What a neat place.
After some setbacks, Young and Duke was finally on the moon. They landed on the area called Descartes. The Descartes region was chosen because it was believed to contain highland material that could provide insights into the moon's early history and the processes that shaped its surface. The region was characterized by highlands and a high density of impact craters, which could offer a variety of rock types and geological formations for study.
Our flight plan originally had us landing on the moon and then getting outside right away, put on our backpack and go out for our first exploration. But due to the 6 hours delay, NASA decided they were going to cancel that first EVA and put it after the rest period. So that meant we took off our suits, we put up our hammocks, and I had the communications cap on. We call it the Snoopy cap, and so I was monitoring the radio in case Mission Control wanted to wake us up for a problem. And they had told me that 4 hours into our rest period, a master alarm would go off because of a problem with one of our reaction control systems. So, I mean, I'm all keyed up and I'm laying there, and waiting for this alarm to go off. And when it did go off, I mean, I was jumped almost out through the top of the roof. It was really loud. So I handled the problem and I told Mission Control, I said, I haven't had a bit of sleep. I'm going to take a sleeping pill. And so they agreed. And so I ended up probably 3.5, 4 hours sleep that night.
Apollo 16 had scheduled 3 moonwalks, but since they had to wait on the orbit for 6 hours, they might cancel the last moonwalk. They didn't decide right on. They will wait to see how consumables will hold on and decide after.
Okay. They are mysterious and unknown decards. Island planes. Apollo 16 is going to change your image. Oh, look at those beautiful rocks. Oh, is this ever neat, Charlie? Okay, I'm out. Almost. Well, don't come out until you see what we just passed over. It was a big rock, I'll tell you. No, it was a big hole. Big hole, huh? Yeah. You ain't gonna believe this. Okay, close the hatch. Oh, is this ever nice? No, is this great?
Sounds great.
You can see the, it's as easy as we... Okay, John. You can see in the shadows just great. Yep. Oh, look at that landing. You almost got a big rock with about a 50-centimeter rock with the right leg, the left leg. Surely. That was a slight miscalculation on the ETB. Fantastic. Oh, that first foot on the lunar surface is super, Tony.
After getting out from the lunar module, John and Charlie prepared the lunar roving vehicle. This vehicle first used in Apollo 15. The farthest distance astronauts could travel away from their lunar module was 1.2 kilometers during the Apollo 14 mission, while the Apollo 15 mission covered a distance of 30 kilometers thanks to the new vehicle brought along.
When you see the lunar rover on the ground, your first question is, how can that thing possibly be stowed aboard the lunar module? Where does it fit? Well, it is stowed in what we call Quad 1, which is just to the left. As we look out to the hatch, the front hatch is just to the left of the steps. The rover can be stowed on the lunar module because it folds up much like an airplane landing gear folds up into the wing of an airplane. Since the rover does not have a steering wheel, we steer and apply throttle through one stick, if you will, that sits between the 2 crewmen. To go forward, you just tilt the controller forward. To steer right or left, you tilt the controller right or left, and the wheels respond. It's a very sporty little vehicle in steering, because with a 4-wheel steering, you can turn around 360 degrees within the own radius of the rover. So you get a very tight turn out of it, and which is useful for navigating around craters, but at top speed it makes it a sporty proposition to drive.
There was US flag there on them feathers. Looks good. Makes you proud to be an American, Tony. An experience like this. Yahoo! Tony, this is so great you can't believe it.
I believe it, Charlie.
It's winning, John. Look at it go, would you, Charlie? He's got all your steering. It's great. Oh, this is going to be some kind of different ride.
John and Charlie set up and operated the rover. The rover is equipped with a camera to share images with Earth. This camera is controlled from Earth.
Hey, we've got a picture.
Hey,
the ground, no doubt.
Out of the ground.
That's it. Yeah. That's nice looking ground. Okay, the camera is running. The 16 millimeter is running.
Outstanding.
Outstanding. Okay, get the other deck out.
This mission's full of firsts.
Little first, but they're mean something.
Oh, is this easy to do?
Personally, anyway.
Gravity. I really like it. This is about the neatest thing I ever saw.
Hey, you're looking at me with the big eye.
All right, the big eye's on you, Charlie.
Well, it was, of course, very, very exciting to land on the moon. One of the primary reasons we didn't think we were going to get to land. We had a very serious problem that developed in the other spacecraft about 6 hours, about 1 hour before we were to land. And so we had to abort the landing. And so you can imagine how depressed we were, but we orbited twice. And Mission Control said, well, we know the problem, we can't fix the problem, but here's the way to work around the problem, and so now we're going to give you a go for landing. We had some problems also, but nothing as serious as Apollo 11, and John made a terrific landing in the middle of the Cayley Plains and the mountains of the moon, and we were almost dead level in altitude when we touched down. Very exciting. Now we're on the moon, and we just erupted with joy, if you will, and I screamed out, "Old Orion," which was our call sign. "Old Orion is finally here, Houston. Fantastic." As Buzz Aldrin said, magnificent desolation. So it's one of the most spectacular places I'd ever seen. Untouched, unspoiled. You had this reverence about it almost. I'm on the moon. Nobody's ever been here before. And yet you felt the excitement, the awe, the beauty, all of those feelings were within, but you were having fun doing it.
Now it was time to deploy the American flag.
And Tony, the rover tracks are just, they're barely sinking in.
Hey, we can see that.
You can't put it too far down in the middle of the...
Say again, John?
Okay, there it is. Okay, I've got it in there now. Hey, John, this is perfect with the limb and the rover and you and Stone Mountain and the old flag. Come on out here and give me a salute. Big Navy salute.
Look at this. That's a pretty outstanding picture here, I tell you.
Come on a little bit closer. Okay, here we go, a big one. Off the ground, the floor. There we go.
Then.
I like to see an Air Force salute, Charlie, but I don't think they salute in the Air Force. Sure we do. And fly high and straight and land soft.
Okay, Charlie, say when.
Here we go.
Do it again.
One for you. Okay, wait a minute, one more.
This looks like a good time for some good news here. The House passed a space budget yesterday, $277 to $60, which includes a vote for the shuttle.
Wonderful. Wonderful. Tony, again, I'll say it with that salute. I'm proud to be an American. I'll tell you, what a program, and what a place, and what an experience.
Yeah, and I'll say it too. So my country needs that shuttle mighty bad.
9 years from 1972, it's John Young who will command the first space shuttle mission and open a new age in the history of space exploration. The space shuttle program ended after its final flight in 2011. Having completed 135 missions, and experiencing 2 fatal accidents. It left an unforgettable mark on space history, with significant contributions such as the construction of the International Space Station and the Hubble telescope. After 1.5 hours from their first steps, John prepared the telescope that will be used first time on the moon, and Charlie moved the equipments for the experiment package called ALSEP to the selected site.
You can't believe how good that water tastes. I'm gonna take a break, couple of seconds, Tony.
Okay, good show.
56 and 76.
That's affirmative.
Okay. How's the old heart rate looking? Okay.
Even though Charlie couldn't get a response, John's heart rate was 90, while Charlie's was 115. When Charlie was carrying the equipment, his heart rate went up to 140.
Houston, the Earth is maybe a quarter. It's right in the middle.
Outstanding. You did a good down sun alignment in.
I can't believe it. I mean, the crescent is right in the middle of that scope. I might move it 1/2 degree, but I wouldn't move it any more. Man, I'll tell you. Okay, here's the one.
Okay, Charlie, and you're okay.
Reset. Let's go for it. Okay. I just wanted to rest. I'm starting to old.
Right, just take it easy. There's no hurry.
I'm going out with the... Man, look at that bridge, John. Right there. This big sub-rounded. Okay, it's remote in Houston.
Okay, you should have your 2.25 minutes, so anytime you want to go on.
Okay. Reset. Film advance. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Reset. Okay, Houston, it did something besides it moved before I reset at that time.
That's okay, John. Just press on.
It was...
You mean the camera moved?
Reset. Yeah. When I did the 15 seconds and hit the reset, it reset again. It was moving. Like it wanted to take image, like it wanted to go back to imagery. That's going back to Okay, now it's going back to the Earth. It's going back to spectroscopy. Does that sound all right to you guys?
Okay, it should only have done that. Did you reset at the beginning of the 15 seconds?
That's affirmative.
Okay, that's probably the problem there. That thing should have been crossed out on your checklist to do that reset.
Okay.
Okay, hold on a second. We'll regroup here.
You want to say it again?
Okay, John, when it comes back to direct...
How you coming, Joe?
Go ahead and watch for that film advance. And then time 15 seconds from the film advance. Don't do a reset when it comes back to direct.
Okay. Houston, I got about 20 meters away and the RTG package fell off. It hit the dirt with a ton, like a bomb. It got a little dusty, but the fins are okay, and all the experiments seem to be intact.
Good show, Charlie.
We'll knock the. We want to make sure. We want to make sure we knock the dust off those connectors before we take the caps off of them. I agree.
How did it come off that thing?
Okay, it seems to... Okay. Okay, it seems to be locked now, Tony. I don't know what happened. It just, I pushed on it back at the limb, but it just popped off.
5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, reset. Okay, reset again. 3, 4, 5, reset, reset. Outstanding, John.
Okay, it's not, turning, mate. I think we got it that time.
Good show.
The primary purpose of the telescope was to capture ultraviolet images of astronomical objects. Observing in the UV spectrum from Earth is challenging due to the atmosphere's absorption of UV radiation, so placing the instrument on the Moon allowed for clearer and more detailed observations. The telescope was used to study stars, nebulae, and galaxies, providing valuable insights into their compositions, structures, and processes. Additionally, it helped in observing Earth's atmosphere and the auroras, contributing to our understanding of atmospheric dynamics and phenomena.
Taking a break.
Good show, Charlie. Don't strain yourself there. Just take it
Tony,
easy. In fact, just stand there for a while.
I climbed up a little ridge. I am. Man, Tony, this is a real... This ray pattern extends back about 200 meters or maybe more to the east and goes as far as we can see off to the west, which is maybe another 200 meters. I can see Smoky Mountain now, and I can see Dome. Kennesaw is plainly visible with two big craters on its flanks. And if you look towards Smoky, I can see some big craters up on the top, but I can't see Ravine or North Ray yet.
When Charlie arrived at the site, he started drilling the surface. The drill is used to place a thermometer into the deep surface to measure the temperatures. The drill that used in Apollo 15 was made of fiberglass. This material was not strong enough to drill to the aimed level. This time, on Apollo 16, they replaced them with titanium material.
Okay, I can stab it into the ground about... Okay, are you guys ready? Here we go. Mark. Hey, that beauty is going right in.
Outstanding.
Guess what?
It'll slow down.
Stop going in. Something hard in there. Whatever it was, we got through it, Tony. It's speeding up again.
Okay, good show.
Right on down now.
Right.
For now. It must have been a rock. I'm sure the regolith is covered with,
Very good, Charlie.
First, the long stem is in.
When Charlie done with drilling, John came to the site with his rover and they begin to install the experiments.
Tony, on the rim of that little crater, as I walked through there was underneath the regolith, there was a white area. I kicked up some very white soil, about 3 centimeters down. I forgot the camera. All right. Bring it. Okay, Charlie, I got it. Okay. Again, let me have it.
How's that? Watch out for those cables. Okay. I am. That's pretty good.
In the ALSEP experiment, all the experiments were connected to the main center via cable connections to collect the data at the main center and send it to Earth. These cables, which are flat on Earth, curled up due to the low gravity on the Moon. As a result, the cables were scattered everywhere. It was only a matter of time before someone stepped on them and caused millions of dollars worth of damage.
And Tony, the probe is out of the ground up to B8. Right on the line between B7 and B8.
Okay, Baker 7 and 8.
Charlie, what? Something happened here. What happened? I don't know. Here's a line that pulled loose. Uh-oh. What is that? What line is it? That's the heat flow. You pulled it off. I don't know how that happened. Go loose from there? Yeah. God almighty. Now I'm wasting my time. Kind of sorry. I didn't even know it. Oh, it's sure blowing.
Did the wire or the connector come off?
To me. Just broke right at the connector. The wire came off at the connector.
Okay, we copy. Okay, I guess we can forget the rest of that heat flow.
I'm sorry, Charlie. God damn, I didn't even know it. There's a bunch of spaghetti over there.
Well, we can sure see that on TV. It looks like a mess.
John had unknowingly torn the cables in the heat flow experiment. The people at Mission Control worked to find a solution.
So that means you've got to make all those wires, separate wires in there, and have them insulated from one another. That's right. And if that doesn't occur, what are the chances of shorting out the central station?
Well, that's another one that they're working.
They couldn't find a solution. The cables was beyond repair. The heat flow experiment had to wait for Apollo 17. After their work is done in ALSEP site, they prepare to go far away from the lunar module. They will use the rover for visiting other craters. And they started their journey. John was driving the rover while Charlie taking pictures and navigating through the map. They stopped for a rest near the halfway crater. After the quick stop, they moved on to their destination, Flag Crater. They parked their rover near the Plum Crater and began exploring.
There it is. There's the buster. There's Flag. We're here. You did it. We are here. Yeah, was that some crater, Tony? Woo! It's a smooth crater. Very subdued, but it's really steep. And there's some smaller craters, 10 meters or so, on the side.
They were in their first station. They planned various stations for a variety of rock samples near different soil types.
Tony, delineation might be just the, I think really what it is the shadows cast by the sun because the regolith is so unconsolidated, loosely packed.
I think you're probably right. That makes a good study.
Okay, in fact, I'm convinced of that. And, okay, that's two stereo from 7 feet.
Okay.
John, you're just beautiful. That is the most beautiful sight.
What's that?
You're standing there around that crater.
Doggone, I've never heard John described as beautiful.
No? Well, he's not really. Well, actually he is on this thing, I'll tell you. Hi there. Hey, John, I'm going to run on out and look at some of these angular ones out here. Okay. Tony, those lineations are definitely due to the shadows on this loose regolith.
Okay. We're going to have to hustle you on pretty soon, so you better grab those angular rocks.
Now it was time to collect rock samples. They come across with this rock in the edge of the plum crater.
Time flies. Man, I can't wait to get back to Buster, Tony.
Right.
It's really some crater.
As you come around there, there's a rock in the near field on this rim that has some white on the top of it. We'd like you to pick it up as a grab sample.
This one right here?
That's it.
This one right here?
That's it. You got it right there.
Okay, that's a football-sized rock. It's a great Scott size. Sure you want a rock that big, Houston?
Yeah, let's go ahead and get it.
That's a 20 pounds of rock right there. Okay. That's a big class in it, John. It sure is. I fall in the plum crater getting this rock. Smallburger has had it.
Oh, yeah, great.
I got it. That's 20 pounds of rocks.
Don't put it here, Charlie. I just knew you did. Look at the size of that.
I know it. Oh, Tony, it's got some beautiful crystals in it, though. That was a good guess.
Good show.
They named the rock Big Muley. It is the biggest rock sample in the Apollo program. It was 11.7 kilograms. It hit the moon 1.8 million years ago, and it is approximately 4 billion years old. Their time in the flag crater was over. They got in their rover and drove to their second station, Buster Crater.
I'm going to go out and get... Okay, I'm going about a quarter of a diameter away from Buster and sample some more.
Okay.
The rim of Buster's pretty good slope climbing up there, Tony. Okay. The only trouble is you can't put the bag in.
Okay, John.
Okay. Okay, X is 104, Y 403, Z 423. X 107, Y 404, Z 425. Okay, Tony, this is the rock I got here is a very friable rock, and it's the most sharp rock I've ever seen. It's just pure white. The whole matrix is pure white. Okay, and it's not a breccia.
Reed switch is off. And the power switch is off.
I hate to tell you this, but I dropped my bags. I get them. And you come, they can't guess what can happen. The little thing, it came unlocked.
Got to tape those.
No, not that. It was just the top thing. This is really some rock. Really shocked.
Okay, move back. Let me get it on the flight, Charlie.
Okay, and as soon as you can get buttoned up there, we'll be taking off.
Okay.
After their work is done in the Buster crater, it was time to end the first day. They got in their rover and drove to the lunar module. But before getting in the module, they had one last task. During the Apollo 15 mission, which was the first mission to use the rover, the engineers who designed the rover wanted the Apollo 15 crew to test the vehicle on the moon and record the test on video to see how it performed. However, when the video was supposed to be recorded, the camera film got jammed, so they couldn't capture the desired footage. This task fell to the Apollo 16 mission. John instructed Charlie to take the footage, and they began measuring the vehicle's capabilities.
Okay, I'm ready. I'm not going to break it. Let me up to anything.
That's on, Mark. That max acceleration?
No.
Man, you are really bouncing.
Is he on the ground at all? That's 10 kilometers.
Huh? He's got about 2 wheels on the ground. It's a big rooster tail out of all 4 wheels. And as he turns, he skids. The back end breaks loose just like on snow. Come on back, John. And the deck is running. Man, I'll tell you, Andy's never seen a driver like this. Okay, when he hits the craters and starts bouncing is when he gets his rooster tail. He makes sharp turns. Hey, that was a good stop. Those wheels just locked. Mark off.
Okay. Okay, you want to do it one more time?
Yeah.
Got about a minute, 5 seconds that time.
Mark on. Okay, you could have gone the other way. Go ahead. There's the big craters there, though, aren't they?
Yeah, I know. I want to know those holes.
They want 4 minutes worth, John. Well, it's 1 minute and 5. Maybe you can do it twice more.
Surely.
Okay, turn sharp.
I have no desire to turn sharp. Okay, here's the Sharpie.
Hey, that's great. Man, those things, when those wheels really dig in, John, when you turn is when you get the rooster tail. The suspension system on that thing is fantastic.
That sounds good. We sound like we've probably got enough of the Grand Prix. We're willing to let you go on from here. Call that a Grand Prix.
Okay. Man, that was all 4 wheels off the ground there. Okay, max stop.
Okay, I don't want to do that.
Okay, excuse me.
They say that's a no-no.
Okay, DAC off, Mark. Okay, John, DAC's off.
Okay, I have a lot of confidence in the stability of this contraption.
Me too.
After testing the rover, they prepared to get in the lunar module. But after 7 hours in the dusty lunar surface, their suits turned gray. They had to brush all the dust before they get in.
I tell you, Houston, my general impression of this thing is I'm a lot more surprised at how really beat up this place is. It must be the oldest stuff around because it just craters on top of craters on top of craters. I mean, there's some really big old subdued craters that we don't even have mapped on our photo map, I'm sure of it.
Bend over, John.
They just show up as gentle depressions.
Okay, as good as I can do.
Okay, we copy that.
There you go. Okay,
Okay.
Tony, one of those big rock bags those big rocks I could put into the SRC. It's an undocumented rock grab sample. I don't mean the SRC, but the SCB. Why don't we just leave it there and get it for next time, Tony? Tell you what, I'm gonna get it. Bag 5.
Now there's a data point. Just since the time I dusted LaCrue, and right now it needs dusting again. Get some dirt in your eye, Houston. Yeah. Hold still. There you go.
After John and Charlie moved to the lunar module, they had their dinner.
And your biomed looks great down here. Just keep up the orange juice. Push on it a little bit there and everything will be fine. Push on the orange juice and everything will be fine? Yeah, push on the orange juice, Roger. I'm going to turn into a citrus product is what I'm going to do. Oh, well, that's good for you, John. You ever heard of acid stomach, Tony? Well, I don't know about that. Also, since tomorrow's pretty relaxed, we encourage you to get a lot of sleep tonight. You got plenty of time. No need to feel like you got to press in the morning.
Okay, and I think I got a pH factor going for about 3 right now.
Okay.
Okay,
We'll give you a buffer when you get down.
Okay, Tony,
Because of the orange juice. Yeah.
In their meal, they ate shrimp cocktail, turkey, chocolate pudding, and crackers. For drink, they had orange juice. After John and Charlie eat their dinner, they had something to say.
I got the farts again. I got them again, Charlie. I don't know what the hell gives them to me. Certainly nothing. I think it's acid in the stomach. I really do. I haven't eaten this much citrus fruit in 20 years. So I'll tell you one thing. In another 12 fucking days, I ain't never eating any more. And if they offer to sub me potassium with my breakfast, I'm going to throw up. I like an occasional orange, really do. I'm going to be burying an orange. I put them up over the, right up in there. They ain't there? Oh, shit.
All right.
Yes, sir.
Okay, down your way, have a hot mic.
No. How long we had that? Well, unless it was a stuck mic button, that's the only thing we can think of because our configuration was normal.
Okay.
Sorry about that, but that's terrible being on hot mic here sometimes.
Well, you guys have done commendably well considering the fact you didn't know you were on it. I'm very happy with your... Wish we could say the same for some of the people down here.
Thank you.
After eating their meal, John and Charlie set up their hammocks and went to sleep. After 7 hours of rest, they woke up to their second day on the surface. This time, their target was South Ray Crater, about 5 kilometers away from their lunar module. The area where this crater had formed contained older and different rock types compared to Apollo 15's landing site. But since the crater was relatively new, the materials in the area would be less weathered. This would play an important role in studying the younger geological processes on the lunar surface.
That's going to be a steep slope up there, John.
I believe it is, Charlie.
Up stone.
Oh, shoot, man.
Golly. Covered me with dust on that one.
All right, Charlie.
That's okay. Okay, most of the craters here are, there's another split one, but
look at old South Ray, Charlie.
That's beautiful. Just spectacular. I can't believe it. And there's Baby Ray, John.
See it?
Yeah, you can see it. And it's got black sides to it. And you ought to see that Baby Ray, Tony. It's got a real good raised rim. You can see some good, it's got lots of blocks around it that are hard to estimate the size. And we're going up a steep, steep slope, John. I'll tell you.
We believe you, Charlie.
John and Charlie reached their first station of the day, the Cinco Crater Cluster. This cluster of craters is located around South Ray. They named it Cinco, which means 5 in Spanish, because it consists of 5 craters. In this crater, they are looking for glass, rounded rocks. These rock types are formed by the heat which caused by meteor impacts.
There's a look at that glass-covered one right there, John.
Okay, let's get it, Charlie.
Okay. Okay, I'll back off and get the cross sun here.
Yeah, I'm gonna have to get an up sun here or I'll do a lot of work.
It's gonna be just one rock and one bag here. Hey, Tony, we just picked you up a glass Rhine rock. At least a quarter of it's got glass on it, and it's so dust covered that it
defies description.
Defies description.
404. Okay, bag 404.
Y'all got us on the big eye?
We sure do.
Yeah, they do.
Close the top, Charlie.
Okay. Let me try a rake here. Let me get an after.
Get an after, Charlie.
Okay. John and Charlie set off to their next stop after collecting these glassy stones. This time, the place where they will collect samples will be the station closest to the South Ray crater, which is expected to be the richest area in terms of rock samples.
At 0.7, 007 at 2.6, where it's more pebbly than cobbly, being 4 centimeters or so.
My what-you-call-it just fell off.
The SCP?
No, see it, look and see if it's between my legs. Can you see over there? I can't see. I think it fell between my legs.
What thing?
My bags.
Oh, I didn't see it, John. We got plenty of those.
Got plenty?
Yeah.
Okay.
When the pair was traveling to their destination, the fender located on the top of the rover's right tire brake and fell off, exposing them to the sharp lunar dust. Every time the tires were moved, all the dust that's supposed to blocked by the fender came right to them. As if dealing with moon dust while collecting rocks was easy, they would have to deal with this as well.
Look at that beauty, John. That is a crystalline rock, no breccia.
Absolutely great.
An old no breccia crystalline rock, huh? And it is whitish to gray with a lot of zap pits in it.
There is. I maybe run across one. It even has some. It even has what looked to be those are zap pits, aren't they?
Yeah. In fact, Tony, the whole area, there's a lot of this rock. There's a lot of this rock here, scattered around.
Okay, understand. Good. We'll need a picture, and then we'll see if you can turn it over. No, we can't turn that one over. Okay.
Think we can turn that over? Yeah, we might if we grab all this corner. I'd like you to get a big sample first, though. Get a down, son.
Where do you want a sample from?
See that sharp corner? Right up at the top there?
Off the top?
Yeah.
Yeah, I think I can get that. It's fractured right there.
Okay, I was thinking, okay, that's good.
Oh, shoot, look at that. Oh. Now, if that ain't pure planch, I've never seen it.
Doesn't it look like pure planch?
I don't know what it is, though.
It's pure feldspar, it looks like.
Pure feldspar, doesn't look like it's been, it's so sandy looking, it could have been reworked or something.
Maybe partially shocked.
Shocked, yeah.
But it's pure play. It's pledge, Tony.
Okay, we copy that.
And it's in 341. Whack off another piece right here, John.
Okay, I understand it's pretty
And this
fragile.
rock is pretty predominant.
Where, Charlie?
No, it ain't fragile. It's just fractured.
Okay.
Where you want to hit it off, Charlie? Right at that short. See where the nose is? Right there. Yeah. See how that comes off. Pretty friable, isn't it? Yeah. Bad shock. Yeah. Put that in the same bag? Yeah, let's put them all. There's another piece down here. I'll get the tongue. We gotta get the after. Okay, I'll get the after of that right here. Okay, the first two pieces, the first piece was off the top of the rock. The second piece is under the shadow of the Noman shovel. And they're both going in bag number whatever Charlie said. 341. Okay, we have another piece that came out of the same, the second whack.
Okay.
Today's last stop will be a place they visited before, the ALSEP site. While Charlie drills the ground to collect samples here, John will break up surface rocks and boulders to collect samples.
Hey, John, while you're sampling there, you might look around and see if you see any particular basalt.
That's what I'm looking for.
Good show. I told him you were.
Well, okay.
We see that one went all the way in.
Not quite. But there it is, all but about 5 inches.
Okay.
And that one was...
Okay, and John, stand by for a feed water tone.
Even though it is funny to watch them when they're falling, it is dangerous for the astronauts. Sharp lunar dust is easy to get stick, but hard to clean. It can stick to the important parts of the spacesuit, or even cut micro holes, which can be life-threatening.
Okay. Cycling to 14.
Okay, Charlie.
And I'm right by the double core. The deep core.
Okay, that sounds good.
Pretty beat up with... Okay, but it's pretty beat up with footprints. Should I go to a pristine area or stay here?
Just move it over out of the footprints.
Okay, I got a good spot. About 2 meters towards the central station.
Okay.
That one's going all the way in too. I didn't lose my balance.
Good show.
But I can't get up. There we go. Recovery. Bang. Roll heat flow.
Okay, Charlie, one flat plate by the double core, and that'll about do her.
Okay.
After collecting samples for a while longer at the ALSEP site, they brushed off the dust from their suits and returned to the lunar module. Initially, it was planned to reduce their time on the surface by 6 hours, which they had lost due to the malfunction before landing on the moon. However, considering the amount of oxygen and battery usage, they decided not to cut short their time on the surface. Instead, they would shorten the time spent on research in lunar orbit. So John and Charlie will spend their third day on the moon without rushing themselves.
There your tracks. Look at that, John. How far? See them back over there? Looks to me like we just go around the circle here, Charlie. Yeah.
Oh my goodness. We can't see all Orion from here. This is going to be something going on this hill. Sure we didn't, I'm not sure we came up that hill. No, we did. There's the tracks. Sure come up it, didn't we? Look at that slope.
John and Charlie will visit a boulder called House Rock. This rock is 12 meters high and 16 meters wide.
The black clasts in this rock are really black material. It's either a very fine-grained black breccia. I'll tell you what it looks like. It looks like that black breccia fine-grained lining that had that white clast in it on Apollo 15. Although here the matrix is white and the clasps are black.
Okay, understand. How large are the clasps? All right, I remember. Is this black breccia frothy too?
3 centimeters. No, it's not frothy at all. It's dense.
Okay.
It could be a very dense salt-like rock. It is. Its cleavage, I mean, it looks like it has a 9-degree cleavage on it, and I'm hard put to tell that. That's just the way it breaks. But it's sure shot. It's too big to go in the bag, but I'm going to put it in there anyway.
House Rock is estimated to be around 3.8 to 4.0 billion years old. It is composed mainly of anorthosite and breccia, materials that indicate a complex history of impacts and volcanic activity. Its surface shows signs of micrometeorite impacts, suggesting long exposure to the harsh environment of the Moon's surface.
Okay, there's wow. Well, the regolith here, Tony, up on this crater rim is really soft. We're sinking in on these slopes about 6 inches or so.
One rake sample?
Okay, one rake sample right out here, Tony.
Sounds good.
This on a tube.
That's fine.
Going into 4.8 is going in 420.
Okay.
This whole deal.
Oh, he's got some nice ones there.
See what I'm doing.
It
got them in there?
Yep.
Amazing.
And so dust covered, I can't really see what they are. I can't believe all those bags dropped off. Let me put that one in. Okay, where you want to go?
Going back to it.
Oh, I got it, John.
Let me do it.
I got that. Save some energy, it is hot out here. Hey, here, give me my bag. I'll carry the bag. Got it. Okay, Tony, why don't we go down halfway, John, and go another rake sample, and then go on down to the big black rock.
All right.
That. And that's that'll be about a 150 meter radial, not radial, but concentric sampling.
After collecting rock samples for a few more hours, they approached the lunar module, organized the samples they had collected, and prepared to bring them inside the module.
Well, you can bet we're not going to leave anything.
Good show.
Okay. Okay, Tony, the core tubes are going in bag number 7.
Okay, core tubes in bag 7.
And it's hardly got any rocks in it.
After packing up the rocks and equipment, there was just one last thing left to do: Lunar Olympics.
They were going
were gonna do a bunch of exercise that we had made up as the Lunar Olympics. Show you what a guy could do on the moon with a backpack on. But
for a 380-pound guy, that's pretty good.
They threw that out. Yeah, jump flat-footed, straight in the air. 300, about 4 feet. Wow! Charlie, that ain't any fun, is it? That ain't very smart. Well, sorry about that. Right, now we just have some work to do.
After not doing so well in jumping, they tried their luck in javelin throw.
Look at that, Charlie. Clean across the crater. Here goes the javelin throw. Wow. Won't win any world record, but... Okay.
John and Charlie's time on the moon had come to an end. They had become one of the 12 lucky individuals to set foot on the moon, which has been alongside Earth since almost its formation, and witnessed billions of lives coming to Earth. During their 71 hours on the moon, they collected over 90 kilograms of samples, contributing immensely to science. Now it was time for them to reunite with Mattingly, who has waiting in the orbit all alone for their return.
Have ignition, flight. Roger, ignition.
Flight final, positive H-Dot.
Roger, positive H-Dot.
Midcover's on time.
Roger, we call it up.
Order.
John and Charlie rose from the lunar surface towards its rendezvous. The distance between them and Ken Mattingly gradually decreased, and it was time for docking. After docking, John and Charlie removed their spacesuits, joined Ken, and once again experienced the freedom of zero gravity. But there was no time to rest. It was time to send Orion, which had accompanied them for 3 days, back to the lunar surface. The docking latch of Orion was released, and it drifted into the void. However, there was a problem. As a result of the docking, Orion began a 3-degree rotation. The vehicle needed to be stable to use the engines required for a planned descent to the lunar surface. Otherwise, an incorrect burn could have led to a collision between Orion and Casper. As a result, the burn was not executed. 1 year later, Orion, unable to resist the immense gravitational pull of the moon, crashed onto the surface. The impact was recorded by the seismometer installed as part of the ALSEP experiments. After jettisoning Orion, the ignition that would bring them back to Earth was fired shortly after. Following this ignition, now a mission was waiting for Ken Mattingly. He will go outside the spacecraft, into space, to perform some experiments, while Charlie Duke assists him.
Are you ready, Charlie? Yeah, on your egress, you sure will. All set? Okay.
Charlie, can you verify the TV poles aligned?
The module is pretty well blistered. Did the picture shift? Are you not getting a good picture, Hank?
It looks like it might be swung a little too far to the left. We're not sure. That would be the Charlie
Yeah, I'll fix that in a minute. All right. Okay. Stand by.
After spending 1 hour and 24 minutes in space, Ken and Charlie re-entered the spacecraft. Then they entered a long wait of many hours to reach Earth.
Okay, I have two impressions. The first is the dazzling beauty of the cart, the surface. It was just one of the most awe-inspiring sights I've ever seen. And secondly, on the EVA, when you look away from the Earth or the Moon, it's just the utter blackness of space. It really is black out there. I thought I knew someone would ask that question, and I've been asking that question too. And I don't think I can put an impression. There's so many that we've crammed in the last 12 days. And it seems like each one comes on top of the other one, and the immediate response that you come up with is, that's the most fantastic thing I've ever seen. And in a lot of respects, it really is. There have been so many events and so many sights that in my case, I'm going to have to sit and think about this one for a long time before I could ever pick out one. And I'm not sure I'll ever be able to say that there was a unique thing or a most memorable event. The whole thing has been just one series of very impressive, and I hate to use the word, but I don't know anything else except to say it's fantastic. I think Ken's got the answer. I think we've seen as much in 10 days as most people see in 10 lifetimes.
Apollo 16 going through its maximum heat load. This should be 4,000 to 4,500 degrees Fahrenheit, the maximum temperature on the surface of the heat shield.
"71 hours on the surface and 64 orbits around the moon. This was the 12-day journey of Apollo 16.